is the function f of x equals x to the 2/3 differentiable at all points within its domain. Differentiable means it has a derivative, as in a differential, everywhere, and that derivative is continuous. Well, the text does a decent job of walking through this. I thought I would just show it in a slightly different way. A way to check if a function is differentiable is the slope smooth? That means, could you always calculate the limit of the derivative? If you have a person and she's standing right here on this curve, she can report what the slope is. She can say, I'm facing a little bit downhill here. And we could take that person and move her in a little bit. And for a long time, she'd be reporting pretty much the same numbers. This slope looks like it might be minus 0.5, minus 0.5, 0.51. As we get closer to here, the slope begins to get steeper. And if we moved our person in to, say, this position, she'd start to say, yeah, now the slope's more like 0.6 or 0.7, dropping, 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 dropping. And if you imagine her hanging right off the end of her half of the curve, at just to the left of 0, she might say that her slope is something like minus 1.99. I'm making up these numbers, but the point is, she'd be reporting a negative slope value, and if you asked her what would happen if she took one more step to the right, she might guess, I'll bet the slope's going to be minus 2, or something like that. That's the limit as x approaches 0 from the left of the derivative. You can do that. You're just saying the slope gets very close to this number. I'm saying minus 2. I'm not sure what it really is, as you come in from the left side. But here's the problem. If we bring in somebody from the other side and do the same thing, he's reporting positive slopes. He might say the slope is 0.5 here, and then he might say it's 0.6 and 0.7. And as he inches in towards that corner, or what we call a cusp, he'd be saying my slope is about 1.99, and I'll bet it's going to be something like plus 2 if I get right up to 0. And these two limits, negative 2 and positive 2, do not match, which means the two-sided limit does not exist. And we've been taught that means, if the limit does not exist, that means that your function is not differentiable there. So anytime you have a corner, anytime you have a curve that does this with a sharp angle, or what we call a cusp, like so, where the slope abruptly changes direction, the function is not differentiable there, because these two people coming in from the two sides at that point would not agree on what the derivative is doing. A function is only differentiable when it makes smooth transitions from one slope value to the next.